Hi friends at home. Today we're going to work on lesson 17 problem set. And in this lesson, we're going to look for patterns in the multiplication tables. So I'm going to bring up our screen here, or my worksheet, and we're going to get started right away. Okay, this is what your worksheet looks like for today, the template. So I'm going to go through part of it. I'm going to pause the video and let you go and fill in your template a little bit. We can come back and discuss the patterns we see and answer the questions. Okay, so the very first question here says, write the products into the squares as fast as you can. So this is a partial multiplication table. It doesn't have all of our facts on it through 9. But it starts with 1 times 1 up here in the corner, and it ends with 8 times 8 down here in the bottom corner. And the first thing it wants us to do is it wants us to fill in all of the products. So they're giving us the factors. If you remember, factors are the two numbers you multiply, and they want us to fill in the products. So I am going to go ahead and start filling these in. And you'll see in the beginning, it's very easy. If we go across the first row, we have 1 times 1, which is 1, 2 times 1, which is 2, 3 times 1, which is 3, 4 times 1, which is 4, 5 times 1, which is 5, 6 times 1 is 6, 7 times 1 is 7, 8 times 1 is 8. So all of those were our ones. And so we counted by 1 going across. Let's look at our second row. Our second row has 1 times 2, which is 2. 2 times 2 is 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. 7 times 2 is 14. And 8 times 2 is 16. So you can see the pattern there is skip counting by 2s. So if we skip count across this row, we would have 2, 4, 6, 8, 10, 12, 14, 16. So now if we look at our next row, we're multiplying by 3. And when we multiply by 3, that also means we're skip counting by 3. So we can go across this row and we can sing our song. Remember, that's Jingle Bells if we want to. So we could do 3, 6, 9, 12, 15, 18, 21, 24. Okay, and we're going to stop right there because it doesn't have 9 times 3 or 10 times 3, the rest of those facts. Okay, the next row is the 4s. So we could do the 4s by singing our song for the 4s. And if you remember that, that's row, row, row your boat. So I'm going to go ahead and start that for 8, 12, 16, 20, 24, 28, 32. There we go. All right. And of course, the next row is our 5s, and that's really easy. We don't really even need a song for that. So our 5s are 5, 10, 15, 20, 25, 30, 35, 40. All right. Our next row is our 6s. And we can sing our song for that. We can sing, what is it? Deck the Halls. Our next row is the 7s. We can sing Are You Sleeping? And the last row is the 8s. So we could sing This Old Man to help us fill those in. You can also just add 8 more to each previous product that you fill in. So I'm going to pause the video here for just a few minutes, and I'm going to let you go and fill in what we've done so far. And if you want to try filling in the last 3 rows, you can. Okay. Okay, friends, welcome back. Whether you did the last 3 rows or not, it doesn't really matter. We're going to do those together now, so you can check your work, or you can listen to me as I sing. You can sing along with me, and then you can go fill yours in. All right, so our 6s, remember, is Deck the Halls. So we have 6, 12, 18, 24, 30, 36, and 42, 48, and 54 would be 9 times 6. The next row is our 7s, and that's Are You Sleeping? So we can sing that. Sing along with me if you want. 7, 14, 21, and 28, 35, 35, 42, and 49, 56, and 63. There you go. Okay, and now I also want you to notice as we do this, that as you go down the columns, this one right here is your 1s as well. 1, 2, 3, 4, 5, 6, 7. Oh, so we can just put 8 there. This column here is your 2s. So we could go 2, 4, 6, 8, 10, 12, 14, 16. So you can see that the pattern goes across the rows. It also goes down the columns as well. So if it's easier for you to do it like this, to fill in that last row as opposed to try to sing your songs for the 8s, you can. So we have 3, 6, 9, 12, 15, 18, 21, 24, 4, 8, 12, 16, 20, 24, 28, 32, 5, 10, 15, 20, 25, 30, 35, 40, 6, 12, 18, 24, 30, 36, 42, 48, 7, 14, 21, 28, 35, 42, 49, 56. And then our last one, 8, 16, 24, 32, 40, 48, 56. If you want to, just add 8 to 56 and you get 64. Remember the little poem I think I've taught you before, 8 and 8 went to the store and bought a Nintendo 64. That should help you with that fact. Okay, so we got all those filled in. Now, the next thing we're going to do is we want to color all the squares that have even products orange, okay? So I guess first we have to review what is an even number, what is an odd number. So an even number is a number that ends in 0, 2, 4, 6, or 8. An odd number ends in 1, 3, 5, 7, or 9. So let me just see if I can write that up here for us. Even ends in, actually, you know what? I think I'm going to type that up here in a little text box, okay? So even ends in 0, 2, 4, 6, or 8, okay? That's what even numbers end in. And odd numbers, we'll put that over here, odd end in 1, 3, 5, 7, and 9, okay? The other way you can remember even and odd numbers, and I like this way, even numbers can be split into 2 equal groups. So any even number you can divide into 2 equal groups. So I like to think of even numbers as fair numbers. If you have 6 people and you want to divide it into 2 teams that are fair, you do 3 and 3. So 6 is an even number. If you have 5 people and you want to divide them into 2 equal teams, you can't do it. One team would have 2 people, one team would have 3 people, and then that's not fair. 5 is an odd number. So remember, even numbers are fair numbers. They can be split into 2 equal groups. Odd numbers are not fair numbers. Okay, they can't be split into 2 equal groups. Your sides would have different numbers on them. Okay, so knowing that, let's go back and let's color in all of the products. Those are answers to all these multiplication equations, all of our products that are even, okay? So if we look at the first row, we got 2, 4, 6, and 8. Those are all the even ones. 1, 3, 5, and 7 are odd. If we look at our next row, 2, 4, 6, 8, 10, 12, 14, 16. All of those are even. So I'm going to color all those in with orange, okay? Our next row, we have 3, 6, 9, 12, 15, 18, 21, 24. The only ones there that are even are 6, can be split into 3 and 3. 12 can be split into 6 and 6. 18 can be split into 9 and 9, and 24 can be split into 12 and 12. You also see that 12 ends in a 2, 18 ends in an 8, 24 ends in a 4. And remember, here's what we want to remember about how our odd and even numbers end, okay? The next row is our 4s. And if you notice 4, 8, 12, 16, 20, 24, 28, 32, those are all even, okay? The next row are our 5s. And only the 5s that end in 0 are even. So we have 10, 20, 30, and 40 are even. Let's go to our 6s. Let's see, we have 6, 12, 18, 24, 30, 36, 42, 48. All of those numbers end in 0, 2, 4, 6, or 8. So they're all even. The next row, we just have 14, 28, 42, and 56 that are even. And the last row, all of them are even again. So now as we look at our multiplication table, you can see a distinct pattern there. All right. In the first row, it's only every other product that is even. In the next row, it's every product that is even. Here's another one where every product is even. And you can kind of see the pattern we have going on there. Okay. So that's going to be important as we move forward here. All right. Let's look at the first orange square in the table. So the first orange square is 2 times 1 equals 2. And I'm going to encourage you to go ahead and write that on your board here. 2 times 1 equals 2. We're looking at the very first orange square right there. All right. Are the factors in that equation even or odd? Well, we know 2 is even and 1 is odd. So what do we have here? We have an even number, which is 2, times an odd number, 1, and our product is 2. What is 2? 2 is also even. So we took an even factor, multiplied it by an odd factor, and got an even product, okay? Let's look at the next square below that. Let's look at 2 times 2 equals 4, all right? So I'm gonna write that, 2 times 2 equals 4. Let's look at our factors here. Well, 2 is even, times 2 is even, and we got 4. And what is 4? Well, 4 is also even. Whoops. All right. So let's look at what we see here. We see that if we have an even factor times an odd factor, we get an even product. But if we have an even times an even, we get an even product. All right. Let's see. Let's look at another one here. Let's look at odd. An odd product. So let's look at 5 times 1 right here. And let's write that. 5 times 1 equals 5. All right, that was an odd product. Well, 5 is odd, and you're multiplying it by 1, which is also odd. And your product is 5, which is odd. I'm starting to see a pattern here as well. So in our multiplication equations, we can have an even factor and an odd factor. If we multiply those, we get an even product. We can have an even factor and an even factor, like in this example. And when we multiply those, we get an even product. And last but not least, we could have an odd factor times an odd factor, and that would give us an odd, that would give us an odd product. Sorry, guys. I don't know why that's not letting me draw here. There we go. Odd times odd equals odd. All right. So what we want to remember here is these 3 patterns here that I have written in the margin of our page. Even times odd equals even times even equals even, and odd times odd equals odd. All right. So now let's go down to question A. We already colored in all the squares with even products orange. Now we want to say, can an even product ever have an odd factor? Well, let's look at our 3, let me just change the color here so I can bring it to your attention. Let's look at our 3 equations that we have here. Even times odd equals even times even equals even, odd times odd equals odd. Can an even product ever have an odd factor? Well, in our very first number sentence, we have even times odd equals even. So we can say, yes, it absolutely can. So we're going to write, because here's our example right here for that first one. Sorry, guys, I don't know why that keeps going small on me. There we go. So I'm going to write the little text box here, and we're going to answer this question. Can an even product ever have an odd factor? We're going to say, yes, it can, because even times odd equals even. Okay, and that's our answer for the first question. Okay, now let's look at the other one. Can an odd product ever have an even factor? Well, again, if we go back to our 3 examples here, the only time we got an odd product, oops, let me get rid of that text box. The only time we ever had an odd product is right here. And the way we got it was odd times odd. So can an odd product ever have an even factor? Our answer for that one would be no, it can't, because only odd times odd equals even. Really important for us to understand that. Okay, let me see if I can extend this a little bit. There we go. So it's all in my mind. There we go. Maybe move it down a little bit. okay? I'm not sure what happened to my first square, so I'm going to go back and fill that in again. Yes, it can, because odd, even times odd equals even. Okay, and we show those examples. I don't know why that keeps, sorry guys, I'm gonna type it one more time. Even times odd equals. All right. All right. Now, letter C. Everyone knows that 7 times 4 equals 5 times 4 plus 2 times 4. Explain how this is shown in the table. Okay. Well, let's look at 5 times 4. So let's find 5 times 4 in our table. And it's right here practically in the middle. There's 5 times 4. And let's find 2 times 4 in our table. So we're looking for the factor 2 times 4. 2 times 4 is right here. All right. So explain how this is shown in the table. Well, if we look at 5 times 4, our answer is 20. So under here, I'm going to put 20. And then 2 times 4 we found in the table was 8. And 20 plus 8 equals 28. Okay. So how do we see it in the table? We find the product for 5 times 4. We find the product of 2 times 4. We add those and we get 28. That technically is the distributive property. We found 7 times 4 by using 2 easier facts. We all like multiplying by 5. We all like multiplying by 2. And so that makes it easy for us to get our answer there with those 2 easier facts. All right. So explain how this is shown in the table. Well, we can type a little text box here and we can say, we can use the table to find 2 times 4 and 5 times 4 and then add those products. Okay. And if you want, you can write it's the distributive or break apart strategy. Okay, and let's see. All right, let's go to the last one. Okay, use what you know to find the product of 7 times 16 or 8 sevens plus 8 sevens. All right, so 8 sevens plus 8 sevens would be 8 times 7. And if we do 8 times 7 twice, we really are doing 16 times 7, which is 7 times 16 switched around with the commutative property. All right, so we're going to write this in fact form. And I'm going to change my color back to blue here. So 7 times 16, do not want a text box. And what does 7 times 16 equal? It actually equals 7 times 8 plus 7 times 8. Again, what are we doing? We are decomposing 7 times 16 into 2 smaller facts. And we're just going to use the same fact twice. 7 times 16 is nowhere to be found in our multiplication table, but we can find 7 times 8. And so just so you're clear on this, if we look at 7 times 16, which one of those numbers did we decompose? Did we decompose the 7? Right, we did not decompose the 7 because the 7 is right here, but we did decompose the 16, and you can tell that because we decomposed it into 8 and 8. So if we drew a little number bond over here, we took 16 and we decomposed it into 8 and 8, and that's how we got our new fact, okay? Now let's go up to our multiplication table and find 7 times 8. It's in the very last row, and here it is, 7 times 8. 7 times 8 equals 56. So if 7 times 8 equals 56, and this 7 times 8 equals 56, now all we have to do is add 56 and 56 to find 7 times 16. So who would have thought that you could find that product that easily? But we're going to take 56, and we have to add that to 56. And I'm going to show my algorithm over here on the corner of my page or in the margin of my page. And so I'm going to get 112. So 56 plus 56 is 112. What is 7 times 16, boys and girls? 7 times 16 is 112. All right. So there you have it. You can use smaller facts to find bigger facts. If you wanted to do 7 times 18, you would just do 7 times 9 plus 7 times 9. So you can break those more difficult facts into easier facts. You could also do 7 times 16 and multiply it by, this would not be in the, this would not be in your chart, but you could do 7 times 16. Let me erase that, make it a little clearer. You don't have to put this on yours. I just want to share another way that you can use the distributive property here. So if we had 7 times 16, we could still decompose the 16 and we can decompose it into 10 and 6. Why? Because I like multiplying by 10. So I could do 7 times 10, and then I could add to that 7 times 6, and hopefully we'll get the same answer here. 7 times 10 is 70. 7 times 6 is 42. So now we have to add 70 plus 42. And guess what we get? We get 112 this way too. So a lot of different ways that you can get around, now that you know the distributive property, get around finding the products for more difficult facts. All right. Our second page, boys and girls, that we did in our workbook is a landscape page. It was really, I could not figure out how to make it portrait on your work page. So you get off easy today compared to your friends at school. You only have to do this page. Remember, you can pause the video, make sure you're doing everything that I did, fill out the multiplication chart in its entirety. You can sing the songs, you can skip count. Make sure you color in all of the squares that have even products. I want to make sure that when you submit your work to your teacher, this is really important right here, boys and girls, all of this right here, because that is the pattern we're focusing on. Even times odd equals even times even equals even, and odd times odd equals odd. Really important for us to recognize that, okay? All right, I hope you have a great day, boys and girls, and thanks for tuning in.